Alright, so this question says Fred is playing darts. He's throwing at a dartboard with 3 concentric circles. By the way, concentric just means these circles share the same center, and they have radii 3, 6, and 9. This forms 3 regions. We have a small center in the middle, a small circle, and then a middle ring that's a little bit bigger, and then an outer ring. And so we're looking for the probability that Fred will hit the outer ring expressed as a common fraction. So again, let's just draw this out. We have our dartboard. It has a big outer ring, a middle ring, and a center circle. Look at my beautifully drawn dartboard. But in any case, what we're looking for is the probability that the dart will land in this outer center right here, okay? So how do we find that? Well, this question, it doesn't actually explicitly say it, but we're going to assume that Fred has a random chance of hitting anywhere on this board, otherwise we won't be able to solve it. But Fred has a random chance of hitting anywhere on here, right? And so we're looking for the probability that Fred hits this area out of the total places he can land, right? So the way we're going to find that is just, well, it's just the area of that outer ring out of that total area, right? Because there's a random chance of hitting everywhere on that ring. So we're going to find the area of the outer ring and then divide that by the area of the total board, right? To find the probability that Fred will hit the outer ring when knowing he's going to hit somewhere in that total board, okay? Fred is not going to miss. Fred is going to hit somewhere in there randomly. We believe in Fred. Okay, so how do we find the area of these things? Well, the area of the total is a lot easier, right? Because we know that the radii, right, from here to here, that's 3. From there to there, that's 6. From here to the outside, the outermost circle, this is going to be 9. So to find the area of that total dartboard, it's just going to be the area of a circle, which we know is pi r squared. It's going to be the area of a circle with a radius of 9. So the area of the total is going to be equal to pi times 9 squared, so 81 pi. Now, how do we find the area of that outer ring? Well, for this, to find this area, we're actually going to take the area of the entire circle, but we don't want all of that, right? We don't actually care about all of this area right here. That's not included in the outer ring. So we're going to take the area of the entire circle and subtract from it the area of the second biggest circle, right? So the area of the outer ring is just going to be 81 pi, because that's the area of the entire circle, minus the area of this middle circle. So that's going to be pi r squared. R in this case is 6, so it's going to be pi times 6 squared, or in other words, 36 pi. So the area of that outer ring is going to be 81 pi minus 36 pi, which is equal to 45 pi. So that means our probability, if it's area of the outer ring over the area of the total circle, is going to be 45 pi over 81 pi. Now we can simplify this. We can divide both sides by pi, but we can actually simplify it a little bit further. We know that both of these numbers are divisible by 9. So we can just say, once we divide the numerator and denominator by 9, that our probability is going to be 5 over 9. Our final answer is 5 9ths.